Hello everyone, I welcome you in my YouTube channel. I am Dr. Sirajul Faizi. Today in this video, I am going to talk about some basic concept of organic chemistry. I hope this video will be helpful to you. If you like this video, then please subscribe my channel. So friend, now let us start organic chemistry. So what is organic chemistry? So, a study of carbon and its compounds. A study of organic compound or a study of hydrocarbon compounds and its derivatives. Two things involved in organic chemistry or chem: hydrocarbon derivatives. Hydrocarbon means you see here carbon and hydrogens, and derivative of hydrocarbon you can see red one showing oxygens. Few more notes to consider. The building block of structural organic chemistry is the tetravalent carbon atom. With few exceptions, carbon compounds can be formulated with 4 covalent bonds to each carbon, regardless of whether the combination is with carbon or some other element. Now friends, hydrocarbons. A hydrocarbon is an organic compound consisting entirely of hydrogen and carbon only carbon and hydrogen. Hydrocarbon may be aliphatic, aromatic, uncyclic, open structure, saturated, unsaturated, no pi bond formations, or all are single bonded. For example, alkanes contain pi bonds, has double or triple bonds. For example, alkenes and alkynes. In aromatic, factor to consider should be cyclic, closed structure, no triple point, terminal point. Planar 2D structure, has conjugated double bonds, alternating double bonds, and follow Haeckel's rules. What is Haeckel's rule? Pi electron is equal to 4n plus 2. Now this is the tools. Now friend, in this slide I will discuss about general rule for knowing if it's aromatic or aliphatic. If the organic compound does not follow the 4 general factors of an aromatic compound, then it's aliphatic. So hydrocarbon derivatives are formed when there is a substitution of a functional group at one or more of these positions. Order of priority must be observed. Now here list of functional groups. There are many functional groups of derivative of hydrocarbon. So carboxylic acid, aldehyde, ketone, amide, alcohol, ether, and many more. You can see here carboxylic acid, ester, amide, cyanide, aldehyde, ketone, a lot of derivative. Alcohol, thiol, amine, alkene, alkyne, alkane, ether, halogens, alkyl halides, nitro. So friends, Kekulé formulas. A Lewis structure in which bonded electron pair in covalent bonds are shown as lines. Kekulé was the first to suggest sensible structure for benzene. He said the carbons are arranged in a hexagon and the suggested alternating double and single bonds between them. So look at here: alkane, alkene, alkyne, cyanide, carbon dioxide, their derivative formaldehyde, acetic acid, acetonitrile. Condense formula. To save space and time, I repeat, to save space and time in the representation of organic structure, it is common practice to use condensed formulas in which the bonds are not shown explicitly. You can see here there is no bond like previous slide. In using condensed formulas, normal atomic valence are understood throughout. Look at here: ethane CH3 CH3, and like ethane nitrile or acetonitrile CH3 CN. There is no bond here, so this is the condensed formula. Now friend, 3D structural formula. You can see here acetone, and the IUPAC name of acetone is 2-propanone. So you can represent through the models, or you can write here CH3CO CH3. So there are three types of here bond. One is normal bond line in the plane of the paper or screen where viewed electronically. Dash line bond extended backward. Just remember, bond extends backward away from the viewer, so effectively into the paper, and it is the opposite of wedge bond. You see, wedge bond produced towards the viewer, so effectively out of the paper. So there are three representation: normal bond, dash bond, wedge bond. Friends, Skelter formula, also called the line angle formula. It is represented in 2 dimensions as on a page of paper. A skeleton formula shows the skeleton structure or skeleton of a molecule which is composed of skeletal atoms that make the molecule. You can see here acetone, propanol. So friends, how to name organic compounds? The primary goal of the International Union of Pure and Applied Chemistry, IUPAC, naming system is to create a unambiguous relationship between the name and structure of a compound. With the convention established by IUPAC, no two distinct compounds have the same name. The IUPAC naming system greatly simplifies chemical naming. So steps in naming: identify the longest carbon chain containing the highest order functional group. This is the main idea. This will be called the parent chain and will be used to determine the root of the name. Keep in mind that if there are double or triple bonds between carbon, they must be included. If one of the functional group would provide a suffix for the compound, for example an alcohol, which will be discussed later, then the parent chain must contain this functional group. Keep in mind that the highest priority functional group with the most oxidized carbon will provide the suffix. Now numbering the chain. As a convention, the carbon numbered 1 will be the one closest to the highest priority functional group. If the functional group all have the same priority, numbering the chain should make the numbers of the substituted carbon as low as possible. Look at here position 1 and 2 and 3, because 3 is getting not 1, 2, 3 in different way. Name the substituents. What is substituents? Substituents are functional groups that are not part of the parent chain. A substituent's name will be placed at the beginning of the compound name as prefix, followed by the name of longest chain: T-butyl, neopentyl, isopropyl, secondary butyl, isobutyl. This is the fragment. Now friends, assign a number to each substituent. Pair the substituent that you have named to the corresponding numbers in the parent chain. Multiple substituents of the same type will get both the di, tri and tetra prefixes, and that we have previously noted, and also a carbon number designations, even if they are on the same carbon. So friends, complete the name. Names always begin with the name of the substituents in alphabetical order, with each substituent preceded by its number. Note prefixes like di, tri and tetra, as well as the hyphenated prefixes like normal and tert, means tetra, ignored while alphabetizing. Non-hyphenated roots that are part of the name, however, are included. These are modified like iso, neo or cyclo. The numbers are separated from each other with common and from word with hyphen. Finally, we finish the name with the name of the backbone chain, including the suffix for the functional group of highest priority. So friend, this is the example: 4-ethyl 5-isopropyl 3,3-dimethyl octane. You can look and try to apply all guidelines or rules of IPEC system. So friend, hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.